Hello. So today we're going to do activity 3.2, the ranking the moles, molecules, and mass. But first, before we do that, we have to talk about converting between different molar quantities. So the central theme is the mole. Okay? So we're going to convert everything to a mole. Our mole is always our pit stop. So 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd particles, or N is equal to 22.4 liters of gas at standard temperature and pressure, and it's also equal to molar mass. So this is a tool to get us to understand our conversions. This is kind of our introduction to stoichiometry here. Okay, so let's say my blue represents mass. Okay, which is always going to be in grams, hopefully. Okay, or it can be in volume, which is in liters, or some derivative thereof. So I'm going to say 1 mole here. So volume in liters. And then your last option is to go into particles, the different types of particles there are, whether it's atoms or molecules or whatever it is. Molecules, right? And one of the things that you can do so that you don't mistake molecules and moles is to shorten molecules to cules, right? I have plenty of friends named Drew, right? Their name is Andrew, but they go by Drew, right? In the same way, we can say molecules or cules. Okay, so to get to mass, you use molar mass. For volume, you use 22.4 liters is your conversion here. And your conversion here is going to be 6.022 times 10 to the 23rd. Okay, 6.022 times 10 to the 23rd. Okay, so this is going to be your mole island. We're going to use this up for a couple of weeks because this is our introduction to stoichiometry. Okay. Okay. So coming over to 3.2 and doing the intro, the first thing we need to do is molar mass. So for molar mass, as a review, you just add the masses from the periodic table. So I have 1 carbon, and the mass is 12.01, right? And for hydrogen, I have 4 times 1.01. Use the amount of significant figures that your teacher tells you to use. I personally like to go to the 100th digit. This says to the nearest gram, so we're going to do that. So this is 12.01. 4 times 0.04 is 4.04. So I'm going to add those together to equal 16 grams. Okay, so 12.01 plus 4.04 is going to round to about 16 grams. Okay, for here I've got 2 times 12.01, which is going to be 24.02. And then hydrogen, I have 2 times 1.01, which is going to equal 2.02. Rounding that out, 26.02, which I'm going to say is 26 grams. Okay, and then for C3H8, I'm going to have 3 carbons, each 12.01, which is going to be 26.02 grams. And 8 times 1.01 for hydrogen is going to be 8.08. That's going to come out to 34 grams. Okay. Let me make sure 6 plus 8, yeah, it's 14. Okay, very good. So you should be doing this on your own. So if you need to pause the video, you can. Okay. If you had samples of each of these substances, CH4, CH2H2, and C3H8, and all 3 samples contain 0.5 moles of molecules, which sample would have the largest mass? Okay, so you should pause the video and write your reasoning, and then I'm going to write my reasoning now. Okay? All right, so if I have 0.5 moles of each one, I'm ranking greatest to least. I'm going to say C3H8, and then C2H2, and then CH4. And my explanation is going to be because C3H8 has the greatest mass. It will have the greatest mass at 0.5 moles, right? So since 0.5 times 34 is not that hard, I'm going to say at 17 grams. Okay, because 34 divided by 2 or multiplied by 0.5, which is the same thing as divided by 2, is going to be 17. Okay, C2H2 has a mass of 13 grams for 0.5 moles. And then CH4 will have 16 grams at 0.5 moles. Okay, and so I was able to do that math easily. If you should be showing your work. Let's just go ahead and do that, right? The question tells us 0.5 moles. Using dimensional analysis, if moles goes up here, we put moles on the bottom, and I have 1 mole is equal to 34 grams. Okay, so that's how I did that math. If you had a sample of each of these 3 substances, CH4, C2H2, and C3H8, and all 3 samples contain 0.5 moles of molecules, which sample would have the largest number of molecules? So in this case, CH4, again, you should answer at the same before you go on. So, answer first, then watch the video. So CH4 is going to be equal to C2H2, which is going to be equal, to C3H8, right? And that is because you have the same amount of particles. Okay, so if I have a dozen elephants, then I have 12 elephants. If I have a dozen needles, I have 12 needles. However, the mass of my 12 elephants is going to be a lot more than the mass of my 12 needles, right? So a mole is the same number, right? But the mass is different according to what you're talking about. So 1 mole is always equal to 6.022 times 10 to the 23 we're going to say particles. You could say units. That might be the preferable word. Units will always be equal to 6.022 times 10 to the 23 particles or units, no matter what you are counting. Right? So this is going to be similar to dozen is always 12. Okay, so you could hypothetically have a mole of humans, but Lord, I hope not. Okay? Okay, so this is when we get to the activity. Okay? So here I have my different criteria. So go ahead and label these in your boxes. Okay, my first criteria is going to be number of molecules. My second criteria is going to be my mass. My third criteria is going to be moles. My fourth criteria is going to be grams. My fifth is going to be molecules. My sixth is moles. Okay. And my seventh is going to be mass. So let me show you how you're going to do this. Okay. So if you are watching this video, you are, I'm assuming, not in class. Okay. So what you are doing is you are going to you're going to rank these cards. Okay? You're going to rank these cards by choosing them randomly. The way that you're going to choose them randomly is you're going to go to Google and you're going to look up number randomizer. So just look up number randomizer. I have, let's see, not that. I've got 12 cards, so I'm going to make my maximum number 12. Okay, so my randomizer just gave me 1. So the first card that I got is 1. I'm going to go to my randomizer again. I'm going to get 7. And then I'm going to randomize again. I got 1 again. I can't do 1 and 1. I'm going to do 3. Okay, so you should have 3 different cards. Okay, so looking at my cards, I'm going to say number 1 is 16 grams of CH4. If I look at my cards, number 7 is 22 grams of C3H8. And my last card is going to be 2 mole of CH4. Okay, so I am going to convert all of these to molecules before I check my work. Okay, so I'm going to use that under my explanation. So if I want to go to grams to molecules, because I'm saying number of molecules, I'm going to use my conversion sheet here. Okay, conversion sheet here. So my given is 16 grams of CH4. Okay. All right, if grams is here, I need to go to grams here. Okay. I can't go grams to molecules automatically. I have to go grams to mole first and then go moles to particles. So 16 grams, I calculated my molar mass before for CH4. CH4 was 16 grams. Is equal to 1 mole. And you should get used to writing the chemical formula in here. I know it's redundant, however, when we go into stoichiometry, which is coming up quick, you will not regret doing this work. Okay? And then I know that 1 mole is equal to 6.022 times 10 to the 23rd molecules compared to 1 mole. Okay? I'm going to do the same thing here for number 7. So I'm just going to do my work first. Do 22 grams, C3H8. If you are in my class, you are welcome to use this as your first box. Okay? So C3H8, my molar mass, is going to be 34 grams of C3H8 is equal to 1 mole of C3H8. Then 1 mole 3H8 is going to be equal to 6.022 times 10 to the 23rd molecules or cules of C3H8. Okay, and then finally for number 3, I'm going to do 32 moles of CH4. If moles is here, I'm going to do moles here. So 1 mole. And here I can go straight to cule. Okay, so particle is going to be 6.022 times 10 to the 23rd cules. Okay, so again, if you start with something and end something that's not mole and end with something that's not mole, you have to go through mole first. If you're starting with mole or ending with mole, you can stop there. Okay? Okay, so now I'm just going to show you how to put it in the calculator just in case you forgot. Okay, so in this situation, 16 cancels out 16, so I can just cancel those out. All right, let's cancel out our units too while we're canceling things anyway. Oh, so actually this is very convenient, right? This is equal to 6.022 times 10 to the 23rd molecules. Okay, this one is not so easy. Okay, so now this is going to be 22 times 6.02. Remember EE, so that's second EE, 23. So I multiply everything on top and then I divide by what's on the bottom. And so that's going to be 3.89, actually, 3.896 times 10 to the 23rd joules. Okay. And then finally, I'm going to have, get rid of all the excess stuff, 32 times 6e 6.022 E23. And I'm going to equal 1.927 times 10 to the 25th joules. Let me make sure I did the last one right. 22 divided by 34 times 6.02 to E23. Okay, I just wanted to make sure my exponents were right. Okay, if I were looking superficially, I would say that this is the smallest and this is the largest. However, we need to look at the exponents as well. Because this exponent is 25, I definitely am bigger than these two. So the team's ranking from greatest to least, I'm going to say 3 is first, then 6, then 1, and then 7. Okay, 3, 1, and then 7, because 1.927 is the biggest, times 10 to the 25th is the biggest, then 6.022 times 10 to the 23rd is in the middle, and then the smallest number is 3.896 times 10 to the 23rd joules. Okay, and then what you can do is go over to these cards. It's actually a little bit difficult for me to spatially recognize these, to be honest. All right, so if 1 is on the left side, then when I flip it over, it's going to be on the right side. Right? Okay. So oh, actually, okay. So 16 grams is the first one, right? And if I look at molecules, right? It says 6 times 10 to the 23rd. Okay, if I go down to answer 22 grams, it says I have 3 molecules, which sounds like a rounding error to me, because I got 3.896. It might be a difference in the decimal points that you use. And then card number 3, which is 2 moles. So I look for the card that says 2 moles, which is probably here, right? And it says that I have 1.2 times 10 to the 24th molecules. Okay. So that is how you do that. I'm going to read the directions and see if I need. So to end the activity, it's actually been decided that we are going to use a couple more of the criteria So on the document, we will tell you, so on your assignment, we will tell you what your criteria will be, whether it is going to be the mass of the molecule, or the number of molecules, or the mole of molecules. There are also the options to break it down by hydrogen. So grams, mass of hydrogen, number of hydrogen atoms or moles of hydrogen, or grams of carbon, carbon atoms, or moles of carbon. So make sure that you read the document and follow those directions for what criteria you are supposed to use. Okay, so that is Lab 3.2 or Activity 3.2. If you have any questions, please let us know. Have a good day. Bye.